Welcome back. I think I'm moving pretty fast, and now we're getting into some of the topics which, if you're doing further maths, you would do it in year 12. But if you're doing just A level math, there is a good possibility the topics I'm going to do today, this particular lesson and the next lesson, perhaps would be something which you might have done in your year 13. Okay? Oh, by the way, my name is Sosale Mohana. I have taught maths for over 50 years, 40 of which have been used up in teaching the British curriculum, A-level maths and further maths in Kenya and in England. And the first 9 years, of course, I taught the Indian A-level equivalent of the Indian A-level syllabus, which is the CBSC, we call it as. And I hope these videos are useful to you people. As I go over the various topics you have learned, this is more of a revision. Thank you. Let's get on with it. So we are still in topic 3. We are still doing algebra. Today, now that we have done logarithms, I want to start with infinite geometric series. See, you all to recollect what you have learned in geometric series during your lessons in school and the lesson which I did a couple of, I think, about 10-15 videos ago. A geometric series is A plus AR plus AR squared plus AR cube, etc. plus AR power n minus 1. Alright? And of course, R is a common ratio. That means this is U1, U2, U3, U4, U5, etc. UN. If U2 over U1 is U3 over U2 is U4 over U3, etc. equal to UN minus 1 over, UN over UN minus 1 is R, the common ratio. Let's look at it this way. Simple example. Suppose for a moment, I assume that R is 0.1. A may be anything. A may be at 100,000. But imagine 0.1. 0.1 squared is 0.01. 0.1 cube is 0.001. 0.1 power 4 is 0.301. So when you multiply the same number A continuously by R squared, R cube, or 0.1 squared, 0.1 cube, the terms start becoming smaller and smaller and smaller. Because 0.1 is basically 1 over 10. 0.01 is 1 over 100. 0.001 is 1 over 1000. So your denominator is becoming bigger and bigger and bigger and bigger. Remember when we did the asymptotes, the function y equal to 1 over x. As x becomes bigger and bigger and bigger, the value of 1 over x becomes smaller and smaller, then we call it convergent series. Then, so 0.1 is what? What about if it is minus 0.2? Fine. Minus 0.2 is minus 2 over 10. Square it plus 0.04. It is 4 over 100. Multiply by another minus 0.2. It is minus 8 over 1000. Again by minus 0.2 plus 16 over 10,000 minus 32 over 100,000 plus 64 over million. So what is happening? Yeah, it's going a plus and minus and plus and minus and plus and minus, but the absolute value, the modulus of the term AR power n or the nth term is becoming smaller, smaller, smaller. So as long as the value of R is a fraction, is a number between -1 and 1, less than 1, the modulus value. Any number between -1 and 1, the absolute value is less than 1. Then r power n tends to 0. Then this series is called an infinite geometric series. So therefore, this was only a, so if we use the condition, if modulus of r is less than 1, that is -1 less than r less than 1, then the series is said to converge. In which case, let's look at the formula here. Sn was a times 1 minus r power n over 1 minus r. Remember, as r is very small, as n becomes larger and larger and larger, r power n tends to 0. Remember, I told you, it will never be 0, but it is so small that it is almost 0. So therefore, as n tends to infinity, r power n tends to 0. So you have sum to infinity, we call it as s, equal to, look, that becomes 0, it's a over 1 minus r. Then, and the sum to infinity s equal to a over 1 minus r. I don't think a over 1 minus r formula is in the formula book, but you can always figure out taking the Sn formula and assuming that r power n practically becomes 0. Theoretically, it's never 0. Right. So sometimes the question says, you will be given some values, you will be asked to find some values of r and show that the sum to, find the sum to infinity where it exists. That means if you get r as 2/3 and -2, you must take the value 2/3 because 2/3 is less than 1. You understand that? So, or maybe sometimes they say, find the number of terms for which the sum to n terms is within 2% of sum to infinity. Something like that. Questions like that do come. So I'll take some examples and show you how to do these. Of course, I have to make up some questions. And let's see. Yeah. A geometric series has first term 5 and common ratio 0.2. Use 0.2. Find the smallest value of n for which the sum of the first n terms is within 1% of its sum to infinity. Yeah. So I'm interested in finding the smallest value of n for which sum of n terms is within 1% of sum to infinity. So look, a is 5, r is 0.2. So what is Sn? A times 1 minus 0.2 power n over 1 minus 0.2. So it is 5 over 0.8 times 1 minus 0.2 power n. I can simplify 5 over 0.8, and I have seen students simplifying them. Don't. There's a reason why you don't do it. Hang on, I'll show you. What is the sum to infinity? Is a over 1 minus r, which is 5 over 0.8, which you already have. Yeah? What do you mean by the sum to infinity? So sum to n terms is within 1%. That means the difference between the sum to n terms and the sum to infinity is less than 0.01% of sum to infinity. Do you understand that? Oh, less than 1% of sum to infinity. So therefore, I have to rub this off, sorry, because I should have written the question on the side. As usual, as I make up my question, I just continue. So therefore, sum to infinity minus sum to n terms is less than 1% of sum to infinity. So, sum to infinity is 5 over 0.8 minus sum to n terms is that is less than 1% is 0.01 of sum to infinity. Now, do you understand why I did not get rid of the 5 over 0.8? Because I can divide throughout by 5 over 0.8. Of course, nothing big about it, because you can always say it has a 4 over 5 and then 25 over 4, 6.25. You could do that. But why waste time? It's going to get cancelled. Otherwise, you will end up, some of you will end up opening this bracket, subtracting. Oh my God. So I find it easier this way, but you can always simplify if you want to. So divide throughout by 5 over 0.8. So what do I get? So simple. So 1 minus 1 cancels. So it's 1 minus 1 plus 0.2 power n less than 0.01. So 0.2 power n less than 0.01. This is the equation I have to solve. That's the reason why we do inequalities. That's the reason why we do logarithms. Or that's the reason why you learn your multiplication, which is the hardest way of doing it. 0.2 squared, 0.2 power 4, so on and so on and so on and so on. But it's easier because I'm trying to bring out something important here. So obviously, since the best will be take logarithms. But before taking logarithms, remember in inequality, I will put it as an equal to find the critical value. So 0.2 power n equal to 0.01. Why am I doing it that way? I'll show you very shortly. Let me do it this method. This is called a safe method. Then I'll show you a correct method, which sometimes can be unsafe. So take logs. Log means to base 10. 0.2 power n is equal to log of 0.01. So n log 0.2 equal to log 0.01. So n equal to log 0.01 by log 0.2. You didn't write any value there, by the way. I have brought my calculator today. I'm not using the phone. Am I not clever? I thought you people might, sir, you tell us not to use phone. Now teachers tell us in the class, you are using the phone. That's a bad example. So, here is my calculator. Log 0.01, no, 0.01, yeah, divided by log 0.2. Oh, this word calculator requires a base. My God. Log to base 10, 0.01 divided by log to base 10. It proves my point. A logarithm without a base doesn't make sense. And calculator is blindly following that. Whereas we also accept that log means log to base 10. Well, we learn every day, don't we? Over 0.2 equal to 2.8613. That was very quick. 2.8613. So look, the moment n is 2.86, 0.2 power n will be equal to 0.01. But I want it to be less than, so you must cross that. So therefore, n equal to 3. I made up this question, otherwise normally they will say 10 power minus 6 or minus 7, in which case it will be slightly longer. So 3 terms are enough. Anyway, what if you forgot this? The safe method. Fine. Let's do the other one where I'll show you a slight pitfall. This is where you need to be careful, because sometimes the exam says show that it's 3. So I'll take the equation as it is, 0.2 power n less than 0.01. So I can take log of 0.2 power n less than log of 0.01. So therefore, n log 0.2 less than log 0.01. And this is a typical, I'll put it in red. This is an unsafe method. It works, but it's an unsafe method because, so this is the wrong way. So n less than log of 0.01 over log of 0.2. The question said the least value of n. That means it has to be more than. You're going to get n less than. Now, where do you think you have gone wrong? Or I have gone wrong? Since I'm doing the question, I will show you why. Open your calculator. Look at log of 0.2. What's log of 0.2? Log to base 10, 0.2. Log to base 10, 0.2 is negative 0.6989 blah blah blah. Okay. When you divide by log of 0.2, when you divide by log of 0.2, you are dividing by a negative number. So if in the exam, if you write this, the examiner knows you do not know that log of 0.2 is negative. So the correct answer is n greater than log of 0.01 by log of 0.2. Well, sir, how am I going to remember this? Nothing wrong. Don't do it that way. Instead, put in the values. So n times, what's log of 0.02 or 0.2? Log base 10 0.2 close bracket equal to syntax error. Stupid. Okay. I know that's because I put an extra bracket which wasn't needed. Calculators can be stupid at times. Minus 0.69897. Minus 0.69897 less than log of 0.01 should be minus 2. Why it's 10 power minus 2? But let's confirm. So I'll go back. Cancel. Oh my god. Log base 10 0.01. Yeah. Log base 10 0.01 minus 2. So then you know, you will remember from your inequalities that when you divide by a negative, you have to reverse the inequality. So n is greater than 2 over 0.69897. So of course you will find out n is approximately 3. The point, n is 3, because if you do it here, you get n less than 3. and you will say n equal to 2. Obviously, from this stage, you will lose a method mark and an answer mark, 2 marks. Some students are very clever. They know it has to be least, so it has to be more than something. So they get n is less than 2 point something, therefore n equal to 3. Still, the moment you use this and don't change the inequality, you lose the mark, because right answer by wrong method is wrong answer. Be careful. Right answer by wrong method is wrong answer. So you'll have to be careful there, okay? So if you want to continue the inequality, make sure you put the values. There will be a change of sign. But if you don't want to, as we did in inequalities, find the critical value and use it. I want to stop at that stage. I'm going to take 1 or 2 different examples in the next lesson and some standard questions as well on how to apply infinite geometric series. So when we infinite geometric series. So in the next lesson, I'm going to do that. If by any chance when you come back, you see the topic and the title, it is I'm trying to save time writing the whole thing again. Okay. In fact, to make it easier, I will also say -1 less than r less than 1, and then s equal to a over 1 minus r, Sn equal to a times 1 minus r power n over 1 minus r, un equal to ar power n minus 1, and then un over un minus 1 is equal to r. I need all that information, so I'm just putting it there, where a is the first term. That's for the next lesson. So I'll see you later in the next lesson. If you pass by, you're welcome. Otherwise, if you have understood, God bless you. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.